So now the second one, very important part, what we have, switch statement. Listen. So very important for exam, switch statement, right? So how many conclusions you can expect under switch? Ayo, hardly one or two. How many important loopholes are there under switch? 3, 4, 5. Okay, well, listen. So hardly you can expect minimum 10 conclusions about a switch. So very fortunate, most of these conclusions are don't know. I mean, you people don't know most of these. For most of the people, these are new things only. Take special care. So even it is a very basic concept, but there are several loopholes are there about this switch. Here, observe, if several options are available, sir, several options are there, never recommended to go for if else. Never recommended to go for if else. What is the reason for that? Simple. Sir, yeah, if x is equal to 1, if x is equal to 1, sir, can you print SOP of John? Else, if x is equal to 2, sir, can you print SOP of Peb? Else, if x is equal to 3, system.out.println of March. Else, if x is equal to 4, x is equal to 4, like. Are you getting? If several options are there, never recommended to use nested if else, and so on, or else if, like, automatically readability of the code is going to be down. How we can handle? If several options are available, highly recommended to go for switch statement, right? Now observe, same code I will explain with respect to switch. Sir, switch of x. Here, case 1, switch of x, case 1, system.out.println of John break. Sir, if x value is the 1, it is the John break, January. Case 2, system.out.println pep and then break. Pep and then break. Case 12, system.out.println DEC, like I am taking. Are you able to understand? So if you consider this one and this one, which one is the more readable? Second one, obviously. If several options are available, never recommended. If several options are available, never recommended to go for what? Switch statement. Never recommended to go for if else. Highly recommended to go for what? Switch statement, right? Are you able to understand? Okay, this is, make sure you should aware, because readability of the code by default will be improved, right? Okay, this is, what are various loopholes and what is the syntax I will discuss first. Add. If several options are available, several options are available, then it is not recommended, to use nested if else. Not recommended to use nested if else. Because it reduces readability. Next, to handle this requirement, we should go for switch statement. To handle this requirement, we should go for switch statement. To handle this requirement, we should go for switch statement. Okay, like now, what is the syntax for switch? Anna, if you observe, what is the syntax of switch statement? Sir, syntax. Listen carefully, Anna. Sir, here switch off x. Switch off x. So case 1, action 1 break. Case 1, action 1 break. Case 2, okay, action 2 break. Case 2, action 2 break. Case n, okay, case 1, case 2, case n, okay, action n break. Sometimes we may consider default also. We remember default. So here default action. Default is nothing but default action, like. Are you getting? Simple. What is the syntax for switch statement? Is nothing but like you should aware. So based on this syntax, there are several loopholes are there. That part I will discuss. First, take this syntax. Switch off x. Case 1, case 2, like case 1, action 1 break. Case 2, action 2 break. Case n, action n break. Default action. Default itself is default action. Are you able to understand, right? Default action. Okay. So now make sure the first loophole. Let me explain the first loophole itself. Let me talk. Completed, right? Now let me go for first one. Sir, can you tell what is the argument to the switch statement? What is the argument? Argument to the switch statement. Can I take int type or not? Int type. Can I take byte type? Byte. Yes. Short type? Yes. Long type? No. Long type? No. Can I take char type? Char type. Valid or not? Valid. Can I take string type? Okay. Listen this one. Sir, switch off x. Very important part. Sir, which types are allowed and which types are not allowed? Why these are allowed? Why the remaining are not allowed? You should have clarity. Sir, until, so here just observe the allowed argument types for the switch statement are byte is allowed, short is allowed, byte is allowed, short is allowed, char is allowed, int is allowed. These are the only allowed types for the switch argument type. Boolean allowed or not allowed? Not allowed. Long not allowed. Float not allowed. Double not allowed. Why? So why Boolean is not allowed? Or why long is not allowed? Why float is not allowed? And double type not allowed. By mistake, if you are taking this comparative method, you are going to get. Just observe the reason for that. Sir, if I am taking Boolean, by mistake, if Boolean allowed, assume Boolean allowed, then how many cases are possible? Case true, case false. If only two options are there, better to go for if else. Why we are coming to the switch statement? Are you getting that? That's why. So if I allowed Boolean, if else and the switch statement, there is no difference. That's why Boolean type is nothing but not allowed. Are you able to get? Sir, why long type is not allowed? Can you tell int type allowed or not allowed? Allowed. Can you tell what is the range of int? Minus 21, 47, 48, 36, 48 to minus 21, 47, 48, 36, 48 to 21, 47, 48, 36, 47. Sir, inter-range is nothing but this one. Then these many number of cases we can take. Sir, case 10, case 20, case 30, case 21, 47, 48, 36, 47. These many number of cases we can take. In Java, is there any programming requirement where more than these many number of cases are required? Never. So these many number of cases we never go for. Hardly 4 or 5 cases or 10 cases or 20 cases we can. Is it even this much case also not required? More than this range, never. Are you getting that? That's why long data type is nothing but not required. Because long, these many number of cases we are not required to have sure. Next, why float and double is not allowed? Suppose float or double between 0 to 1, 0 and 1, how many double values are there? 0.1, 0.11, 0.101, 0.001, like infinite number of values are there. If I pass a double type, then how many cases I have to define? Case 0.1, case 0.2, case 0.3, infinite number of cases. Is it possible to define infinite number of cases? No. That's why float and double are not allowed. Is it clear for all of you? The only allowed argument types for the switch statement are byte, short, char, int, but this rule is applicable until 1.4 version only. Are you getting? But from 1.5 version onwards, the corresponding wrapper classes are allowed, because in the 1.5 version, do you know, auto unboxing concept came, correct or not? Because of auto unboxing, primitive and wrapper object, there is no difference. That's why in the place of primitive you can use wrapper object, in the place of wrapper object we can use primitive. That's why the corresponding wrapper classes, which one is the corresponding wrapper classes? Byte is allowed, short is allowed, character is allowed, next integer is allowed. Are you getting? Next, in addition to this, enum type also allowed. Enum type also allowed from 1.5 version onwards, and from 1.7 version onwards. Sir, from 1.7 version onwards we can pass string type also. There is no problem at all. Are you able to get? So just only one conclusion. Sir, which data type elements are allowed for switch argument? Until 1.4 version byte, short, char, int. But from 1.5 version onwards, the corresponding character wrapper classes and enum is allowed. From 1.7 version, string type is also allowed, no problem at all. Clear for all of it at this first point. The allowed argument types, for the switch statement are, the allowed argument types for the switch statement are, byte, short, char, int, byte, short, char, int, until 1.4 version, until 1.4 version, but from 1.5 version onwards, corresponding wrapper classes, and enum type also allowed. Corresponding wrapper classes and enum type also allowed. Enum type also allowed. Next, from 1.7 version onwards, from 1.7 version onwards, string type also allowed. From 1.7 version onwards, string type also allowed. 1.7 version onwards, string type also allowed. Completed, right? Okay, take this diagram. Take this diagram anyway. 1.4 version byte short char in 1.5 version byte short character integer enum. Next 1.7 version onwards string type allowed. 1.7 version onwards string type allowed. String type allowed. Completed, right? Okay, 1.7 version is nothing but string is allowed. Okay, this is conclusion 1. Okay, now the second conclusion. And here say most of the people having the doubt. Second, sir, here switch off x, curly brace open and close. Sir, can you tell these curly braces are mandatory or optional? Mandatory na. Curly braces are mandatory or optional? Curly braces are mandatory. Switch is the only place where curly braces are mandatory. Except a switch, everywhere, if else, for loop, while loop, do while, for each loop, everywhere curly braces are optional. Okay, add. Curly braces are, second, curly braces are mandatory. Curly braces are mandatory. Except a switch, everywhere curly braces are except a switch, everywhere curly braces are optional. Except a switch, everywhere curly braces are optional. Curly braces are optional. Now I have one more conclusion. Sir, here we have case is there. Sir, case 1, system.out.println of 1 break. Sir, default system.out.println def, like I am taking, assume. Sir, among case and default, which is mandatory, which is optional? Case. We can take any number of cases. Default, usually we can take only one. So, among case and default, which is mandatory, which is optional? Case is mandatory. Default, sir, default if you want you can take, otherwise you can ignore, no problem. But at least one case must be compulsory. At least one case must be compulsory required. Make sure both the case and the default, both are optional. Are you getting? Sir, I don't want to take any case. Array, no problem at all. Sir, I don't want to take default also. No problem. Both the case and the default, both are optional. Sir, without the case and the default, an empty switch statement is a valid Java syntax, no problem at all. Are you getting? Both case and the default, both are optional. An empty switch statement is nothing but valid Java syntax only. Just observe here, see this one. Listen, have a look once. Here I am taking class test and so on. Here int x is equal to 10 I am taking. Sir, int x is equal to 10. Switch off x. Int x is equal to 10. Switch off x. That's all. Are you getting? Curly brace open and close. Empty switch statement, is it valid or not? Is nothing but perfectly valid. Are you getting? No compile time error, no runtime error. But don't ask what is the purpose of that switch statement. Okay, this is useless. But syntactically, is it valid or not? Yes. Okay, at this point. Yeah, both case and the default are optional. Both case and the default are optional. Next up. Without both case and that is an empty switch statement is a valid Java syntax. An empty switch statement is a valid Java syntax. is a valid Java syntax. Okay, take this one. Take this example. Int x is equal to 10, switch off x. Int x is equal to 10, switch off x. Curly brace open and close. Curly brace open and close. Itself is valid. Are you able to understand that? Now, just I want to make a small change. What is the change here is, observe. Sir, I am taking system.out.println of hello, like this I am taking. SOP of hello, like this I am taking. Is it valid or invalid? Valid or not? Yes, make sure every statement inside a switch must be under some case or default. Independent statements are not allowed. By mistake, if you are trying to take like this, compile time error by default we will get. Sir, can you spell out what that compile time error? Sir, yeah, compile time error we will get. What that one is? Case or default or curly brace expected. Sir, here either case is required or default is required or close this switch, curly brace expected is nothing but like. So how many compile time errors you are going to get is 9 errors you are going to get. 9 errors, but all are same thing only. First time, yet here this line is what? System.out.println of hello, right? Hello. 9 compile time error. First here compile time error. And then here second compile time error. Sir, I didn't expect that. And then out, I didn't expect out. And then I didn't expect that. And then I didn't expect print. Like 9 compile time errors we are going to get. Just observe. Let me show this one. Sir, here int x is equal to 10. Int is equal to 10. Switch off x. Here let me take system.out.println of hello, like I'm taking. Hello, like I'm taking. Can you tell, is it valid or invalid? Invalid. Do you know? So what compile time error or how many compile time errors we are going to get? Are you getting? So here case, default or curly brace expected. First compile time error have you observed? At a system. Error mark have you observed? System. Second compile time error at a dot. Third compile time error at out. Fourth compile time error at dot. Next print dot. How many compile time errors are? 9 errors by default we are getting. Are you able to understand that? Okay, this is 9 errors. So inside a switch, every statement should be under some case or default. Independent statements are not allowed inside a switch. Okay, add. Inside a switch, every statement should be inside a switch. Every statement should be under some case or default. Every statement should be under some case or default. Under some case or default. That is independent statements are not allowed inside a switch. That is, independent statements are not allowed inside a switch. Not allowed inside a switch. Inside switch. Otherwise we will get compile time error. Okay, take this example. Int x is equal to 10. Switch off x. SOP of hello. X is equal to 10. Switch off x. SOP of hello. What that compile time error we are getting? Case, default or curly brace expected. Case, default or curly brace expected. Like compile time error we are going to get. Case, default or curly brace expected like. Completed, right? So it is also one important case we have. Next, fourth conclusion, legend. Here see, I am taking int x is equal to 10. Sir, int x is equal to 10. Int y is equal to 20. And legend, int x is equal to 10, int y is equal to 20. Switch off x. Switch off x. Here, case 10, system.out.println of 10 break, like I am taking. Case 10 SOP of 10 break. Sir, case y, because we know what is the y value? 20. Actually my target is case 20, but y is already pointing to 20. That's why case y, system.out.println of 20 break, like I am taking. Sir, case y. Okay. Can you tell, is it valid or invalid? Arey, valid or invalid? Yeah. Don't think too much. Is it valid or invalid? Huh? Invalid. Because only one thing is there on the board. Automatically it's always invalid. Huh? Valid or invalid? Invalid. The rule or conclusion. Every case label should be constant expression, not a variable. If I am taking variable part, compile time error we are going to get. Do you know? Compile time error, constant expression required. Constant expression required is nothing but like compile time error, right? But so here case y, every case label should be constant, compile time constant. Suppose if I am taking y as a final, if it is a final means what? Constant. Then is it valid or not? Valid. Remember this one. Okay. Let me show this compile time error, right? Here observe, int x is equal to 10, int y is equal to 20, switch off x. Sir, case 10 I am taking. Okay. Case 10. Anyway, these things whether we are taking or not, forget about. Yeah, case 10. Next, case y I am taking. Have you observed case y? Case y is nothing but invalid, right? Now observe what compile time error we are getting. Sir, can you please read at case y, constant expression required. Same compile time error, right? Suppose if I am taking y as a final int y, is it valid or not? Perfectly, there is no problem at all. Are you getting? Every case label should be constant expression or compile time constant, right? Okay. Every case label should be compile time constant. Every case label should be compile time constant within bracket, that is constant expression, okay. Take this example, int x is equal to 10, int y is equal to 20, int x is equal to 10, int y is equal to 20, switch off x. Next case 10, SOP of 10 break, case y, SOP of 20 break. So immediately we will get compile time error saying constant expression required. Is it clear, right? Constant expression required, like compile time error we are going to get. Okay, just add one theoretical point. If we declare y as a final, then we won't get any If I declare y as final, then we won't get any compile time error. Then we won't get any compile time error. We won't get any compile time error. That's all. Completed, right? So this is another case what we have. So here just observe, in the last session, last point we covered, have you observed, right? Switch off x. Switch off x. This is the example we covered. Int x is equal to 10. Int y is equal to 20. Have you remembered? So case 10 I took and the case y I took. Can you tell, is it valid or invalid? This one we covered already. Is it valid or invalid? This one invalid, because every case label should be compile time constant. So what compile time method we got? Constant expression required. This point we covered already, right? Now if we declare y as final, then is it possible or not? Perfectly, there is no problem at all, acceptable, right? Okay, this is. Now just observe the next conclusion. Is it valid or not? You have to cross check. Now listen this point well. Here I am taking int x is equal to 10. Int x is equal to 10. Switch off x plus 1. Switch off x plus 1. Now case 10 I am taking. System.out.println of 10. Sir, case 10 plus 20 plus 30. System.out.println 60 I am taking. Here break is also there. Sir, can you tell, is it valid or invalid? Alright. Is it valid or invalid? Invalid. Yes, I am sure. Invalid. Can you tell where the problem? Either at x plus 1 or at 10 plus 20 plus 30. Where is the problem? Either at x plus 1 or at 10 plus 20 plus 30. X plus 1 or 10 plus 20 plus 30. So 100% pakka. Is it valid or not? Constant expression, no problem at all. X plus 1. So this one is also valid. Don't keep any doubt. Sir, is there any rule switch argument should not be expression? No, it should be constant expression case label. Here switch argument, you know, x plus 1. X is what type? Int type. Int plus int, what type? Int type. So int, is it a valid or not? Valid int type, byte short char int, allow. That's why this one is nothing but acceptable, no problem at all. So switch argument and the case label both can be expressions. Switch argument can be expression, case label can be expression, but case label should be constant expression. Are you able to understand it? So this example is perfectly valid at this point. Both switch argument and the case label, both the switch argument and the case label, switch argument and the case label can be expressions. Both the switch argument and the case label can be expressions, but case label should be constant expression. Case label should be constant expression. Okay, yeah, this example, right? Take this one. Take clearly. Completed, right? Okay, so this one. Now next one. Okay, here this is another rule what we have. And now for the next one, check your luck. Here see, byte B, oh legend, byte B is equal to 10, switch off B, byte B is equal to 10, switch off B. Here, case 10, system dot out dot println of 10 break. Next, case 100, system dot out dot println of 100 break. Case 1000, system dot out dot println of 1000. Is nothing but like. Next, sir, byte B is equal to 10, switch off B plus 1. Byte B is equal to 10, switch off B plus 1. Sir, case 10, system dot out dot println of 10 break. Case 100, system dot out dot println of 100 break. Case 1000, system dot out dot println of 1000 like. Case 1000, SOP of is nothing but like we have. Can you tell among these which is valid, which is invalid? First one, first one invalid, second one valid. No, both are valid or both are invalid. Simple, legend. And if two things are there on the board, one is invalid, the other one is valid. One is valid, the other one is invalid. Rule, universal rule. So which one is the valid, which one is invalid? First one? Obviously first one is invalid. To make this one as valid, second one automatically will become valid. Correct or not? Oi. Both are valid, or first one valid or invalid? Invalid. Second one valid, don't keep any doubt. So my answer is perfectly correct. Okay, first one invalid, second one valid, right? Why, legend, why the first one is invalid? Observe. B is what type? Byte. Byte, what is the range? Minus 128 to 127. Minus 128 to 127. Sir, B, minus 128 to 127. Case 10. Okay, 10 possibility is there. 100 possibility is there. But case 1000, sir, if it is the byte type, is there any chance to have case 1000? Never, sir. This one is nothing but case 1000. Never be possible. Then why we are writing? Is nothing but like compile time error by default we are going to get here only. Okay. Every case label should be within the range of switch argument type. Do you know what compile time error? Possible loss of precision. Possible loss of precision found. Which one is the found? Found int required byte. Are you getting? Found int, but required is nothing but byte. This one is a byte type, right? Are you getting? But if B is byte type, B plus 1 is what type? B plus 1 is what type? Int type. That's why this one is int. So now switch argument type is what type? Int type. Case 10 possible. Case 100 possible. Case 1000 possible. No problem at all. Are you able to understand? Every case label should be in the range of switch argument type. If it is the byte type, the case labels should be minus 128 to plus 127. If it is the int type, then every case label should be valid int value, right? Okay. Now let me consider this example, right? Here see. Observe this. Here I am taking. Just have a look once. So don't try to just observe. I am taking class test. Here observe byte B is equal to 10. Next switch off. Now switch off B. Switch off B. So case 10. Okay, case 10. Case 100. Case 1000. Like I'm taking. Okay. Case 1000 like this I'm taking, right? Forget about all these things. Just only case 10, case 100, case 1000. Is it valid or invalid? Invalid, because B is what type? Byte type. Then how case 1000 is possible? Now what comparative method by default we are going to get? Just observe this one. Here Java C test.java. Java C test.java. Have you observed? Possible loss of precision. Found int required is nothing but what? Byte. Found int required byte. Okay, this is. But if I can take switch off B plus 1, switch off B plus 1, is it valid or not? This one perfectly valid. Okay, no problem at all. There is no comparative error. Even if I can run this code also, there is no runtime exception, right? Are you able to understand? So every case label should be in the range of switch argument type. Is it clear? So first one is valid or invalid? First one invalid, second one valid, right? Okay, at this theory. Every case label should be in the range of, every case label should be in the range of switch argument type. Every case label should be in the range of switch argument type. In the range of switch argument type. In the range of switch argument type. Switch argument type. Otherwise we will get compile time error. Otherwise we will get compile time error. We will get compile time error. Okay, take this example anyway. Take by B is equal to 10. Switch off B. Case 10. Like, take clearly first one is invalid, but second one valid. B plus 1 is int type, but here B is byte type. But B is equal to 10, switch off B. Case 10, case 100, case 1000. Possible loss of precision. Found int required byte. Found int required byte. But second one byte B is equal to 10. Switch off B plus 1. Case 10, SOP of 10 break. Case 100, SOP of 100 break. Next case 1000, SOP of 1000. Clear, I hope. Okay, next one. Next loophole. Next one, here see this point well. Sir, here I am taking int x is equal to 10. Int x is equal to 10. Switch off x. Sir, case, again, case 97 I am taking. SOP of 97 break. Next case 98 I am taking. SOP of 98 break. Okay. So case 99 SOP of 99 break. Okay. Next, last one, case A. A I am taking SOP of A. Case A. Can you tell, is it valid or invalid? Valid or invalid? Invalid. Valid or invalid? Valid. Is it valid? How many people are feeling it is valid? Valid. Okay. Valid or invalid? 100% pakka. This one is valid or invalid? Make sure invalid. Compile time error by default you are going to get. Invalid. What the reason is? Sir, 97, 98, 99, no problem. But case A. A means what? 97. Sir, already case 97 you took. Then how you can take case 97? So if actually the 97, which case is required to execute is always a problem. That's why duplicate case label not allowed. Do you know what compile time error is? Duplicate case label. Duplicate case label is nothing but like compile time error by default you are going to get. Just observe this one. Don't here, just have a look once. Int x is equal to 10 I am taking. And case, legend this one, 97, okay, case 97, 98 and 99 I am taking, and then case I am taking, A, case A. Now observe, int x switch off x line. Have you observed? Compile time error by default what we are going to get? Duplicate case label is nothing but at which case now we are getting? Case A. Duplicate case label. That's why duplicate case labels are not allowed. By mistake, if you are taking duplicate case label, compile time error we are going to get. Add next point. Duplicate case label. Duplicate case labels are not allowed. Duplicate case labels are not allowed. Duplicate case labels are not allowed. Otherwise we will get compile time error. Okay, take this one. Int x is equal to 10. Example. Int x is equal to 10. Switch off x. Case 97, SOP of 97 break. Case 98, SOP of 98 break. Next case 99, SOP of 99 break. Next case A, SOP of A. Case A, SOP of A, like. Is it clear for all of you, right? So at case A, duplicate case label is the compile time error we are going to get. Duplicate case label like. Completed, I hope. Duplicate case label. Okay. Now the next terminology, and legend this point well. Now the next one. So case label, there are several conclusions we covered. First conclusion, it should be constant expression. It should be constant expression. Okay, first one. Second one, it should be constant expression. Okay, first one. Second, do you know the value should be in the range of switch argument type. The value should be in the range of switch argument type. Now third one, another value should be in the range of switch argument type. What is the third one? Duplicate case label. Duplicate case labels are not allowed. Duplicate case labels are not allowed. Is it clear for all of you? Look at this at this point. At the summary, case label, it should be constant expression. It should be constant expression. The value should be in the range of switch argument type. Next, duplicate case labels are not allowed. Duplicate case labels are not allowed. Duplicate case labels are not allowed. Are not allowed. Like, completed, right? It should be constant expression. Next, the value should be in the range of switch argument type. Next, duplicate case labels are not allowed. Like, I hope is clear for all of you, right? This is a duplicate, case label summary. And next one. So keep subheading fall through inside a switch. Fall through, falling down. Fall through inside a switch. Fall through inside a switch. Fall through inside a switch. Inside a switch. Okay, completed, right? Fall through inside a switch. So what is the meaning of fall through inside a switch? Now again, majority of the people having the doubt in this case. Here observe, I'm taking switch off X. Switch off X. Case 0. Case 0. System dot out dot println of 0. Next, case 1. System dot out dot println of 1 followed by break. Case 1 SOP of 1 break. Case 2. System dot out dot println of 2. Next, default case system dot out dot println of DEF, like we have. So DEF, case 0, case 1, case 2 followed by DEF, like we have. Now if X is equal to 0, sir, if X is the 0, what is the output? If X is the 1, what is the output? If X is the 2, X is the 3, what is the output, right? Now, can you tell if X is 0, what is the output? 0 or 0, 1? If X is equal to 1, 1. If X is equal to 2, if X is equal to 2, 2 or 2 def? 2 or 2 def? 2 def. If X is equal to 3, X is equal to 3, def. Okay? Here observe, small clarity must be required. Within the switch statement, if any case are default matched, from that case onwards, all statements will be executed until break or end of the switch. Are you getting? Until break or end of the switch, all statements will be executed until break or end of the switch. This is called fall through inside a switch. Are you getting? Falling down. So now observe, if X is equal to 0, what is the answer? Now 0 matched. Now onwards all until break or end of the switch. That's why what is the answer? 0, 1. Next, 0, 1 break. If X is equal to 1, sir, this one not matched, but this one is matched. Now all until break. What is the answer? 1. If X is equal to 2, 0 not matched, 1 not matched, 2 matched. Now onwards all until end of the switch or break. What is the answer? 2 followed by def. 2 followed by def, not 2. Okay, if x is equal to 3 I am taking 0 not matched, 1 not matched, 2 not matched, only default. Now onwards all until end. What is the answer? D, E, F. That's all. Are you able to understand what is fall through inside a switch? Is nothing but like within the switch, if any case are matched, from that case onwards all will be executed until break or end of the switch. It is falling down. Falling down is nothing but fall through inside a switch. Is it clear for all of you? But now I have one small doubt. Fall through inside a switch, is it advantage feature or a disadvantage? Are you? Sir, if one particular case is matched, then what is the need of executing all remaining until break? Is nothing but is it advantage feature or a disadvantage feature? Advantage or disadvantage? If it is a disadvantage, why the some people are maintaining this one? They can remove, right? That particular case only will execute. Remaining won't execute, like they can implement. But it is they are allowed means there is some advantage is there. Sir, fall through inside a switch is advantage feature only. What is that advantage, right? And I here see this example well. Sir, I am taking suppose switch of X. Listen this example so that you can see advantage, right? Switch of X I am taking. Now, do you know in the year first 3 months are called Jan, Feb, March. Is Q4 or Q1? Financial year. April onwards Q1 is going to start. Now first 3 months is by default considered as what? Q4. Okay, quarter 4 like. Now case 1, if it is the 1, or if it is the 2, or if it is the 3, the SOP of Q1 break. Are you getting? Q1 break. Next case 4, case 5 and case 6. 4, 5, 6 SOP of Q2 break. SOP of Q2 break. Okay, dot like. Sir, observe, if x value is the 1, then what is the answer? X value is the 1, what is the answer? Sir, this case matched. Now onwards all Q1. If x value is the 2, what is the answer? Now onwards all is nothing but Q1. If x value is the 3, what is the answer? Q1. Whether x value is the 1 or 2 or 3, Q1. 4 or 5 or 6, Q2 is nothing but like this one is the Q4. This one is what? Q1 like. Are you getting? So the biggest advantage here is for multiple cases we can define only one action. Correct or not? Code reusability by default there. Suppose falling down is not there, fall through inside switch is not there. Then how many times I have to write SOP of Q4? Here one time, here one time, here one time. Are you getting? So code reusability we may miss. Are you getting that? So redundancy, code redundancy by default will be there. That's why fall through inside a switch. Is it advantage feature or not? Advantage feature. For multiple cases we can define common action. Is nothing but this thing is possible because of fall through inside a switch. Is it clear? So what is fall through? What is the advantage of fall through inside a switch? Okay, at this point. Within the switch, if any case, within the switch, if any case is matched, within the switch, if any case is matched, within the switch, if any case is matched, from that case onwards, all statements will be executed. From that case onwards, all statements will be executed. All statements will be executed. Until break or end of the switch. 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 This is called fall through inside a switch. This is called fall through inside a switch. Fall through inside a switch. Fall through inside a switch. Next para. The main advantage of fall through inside a switch is we can define common action. We can define common action for multiple cases. Common action for multiple cases. Within bracket, code reusability. Within bracket, code reusability. Okay, like now take this example first. Switch off X. Take this example first. Switch off X. Case 1, case 2, case 3. Next SOP of Q4 break. Next case 4, case 5, case 6. SOP of Q1 break. Dot. Q4, case 4, case 5, case 6. Q1 break. Completed, right? Next up. After that, take this example. Followed by output also. Switch off X. Case 0, SOP of 0. Case 1, SOP of 1 break. Case 2, SOP of 2 break. SOP of 2 like. Take clearly this example followed by the output. Switch off X, case 0, case 1, case 2 default. SOP of def. Completed, right? Next one. Keep subheading default case. So there are few conclusions are there about default case. Sir, can you tell within the switch how many times we can take a default case? How many times we can take default case? We can't use the word only once. Recommended to use at most once. What is the meaning of at most once? Either 0 time or 1 time. Within the switch, we can take a default case at most once. Okay? Either 0 times or 1 time. Can you tell when default case will be executed? If no other case matched, then only default case is going to get in the chance. Correct or not? Next. So here where we can take default? Sir, can I take default case anywhere or only at the last case? We can take a default case anywhere. Anywhere you can take, but there is no change in the rule. Default case will be executed if and only if there is no other case matched. If other cases are not matched, then only default case will be executed, right? Okay, at these conclusions first. Within the switch, we can take a default case. Within the switch, we can take a default case. At most once. Next, second, default case will be executed. Default case will be executed. Default case will be executed if and only if. Default case will be executed if and only if. If and only if there is there is no case matched. If and only if there is no case matched. There is no case matched. Next, third point. Within the switch, we can write a default case. Within the switch, we can write a default case anywhere. Within the switch, we can write a default case anywhere. Within the switch, we can write a default case anywhere. But we can write a default case anywhere. But it is a recommended. But it is recommended to write as a last case. But it's recommended to write as a last case. Last case. Okay. Now listen this example well. Sir, switch off X I am taking. Now listen, switch off X. First case only default case. I am writing first only default case. SOP of def. SOP of def followed by here case 0. SOP of 0 break. SOP of 0 break. Next, case 1 SOP of 1. Case 1 SOP of 1. Next, default sorry, case 1 we took. Next, case 2 SOP of 2, like this I am taking. Analogy. So if x value is 0, sir, if x value is 0, what is the answer? X value is the 1, what is the answer? X is equal to 2, what is the answer? X is equal to 3. Can you spell out what is the answer? X is equal to 0. 0, good. X is equal to 1. 1, 2. 1, 2 or 1, 2 default? 1, 2 or 1, 2 default? 1, 2. Okay, well, X is equal to 2. 2 or 2 default? 2. X is equal to 3. Def or def 0. Okay, listen. So small, some multiple answers I can able to listen. So if x is equal to 0, now first default came. So I have to convey, my JVM will convey, why default, please wait some time. If no other case matched, then I will consider, please wait. Is there nothing but like. Now next case 0, matched or not? Matched. Now onwards, all statements until break or end of the switch. What the answer now? Only 0. Only 0. Now x is equal to 1. First default only came. Why default? Please wait some time. 0, match, not matched. 1 matched. Now onwards all until break or end of the switch. What is the answer now? 1 followed by 2. Only 1, 2, not 1, 2 default. X is equal to 2. Default, wait for some time. 0, matched or not matched? 0, not matched. 1 not matched. 2 matched. Now onwards all until end or break. What is the answer now? Only 2. X is equal to 3. Default, wait for some time. 0 not matched. 1 not matched. 2 not matched. Then obviously default, yes, a default matched. From now onwards all. Now onwards all until break or end of the switch. What is the answer now? Therefore followed by 0, right? I hope you people can aware what the answers are now. Okay, take this example. Switch off X default SOP of def case 0. Like take clearly. any Java code we can write. Within the case, you can write another switch statement itself. Any method declaration you can't, only functionality. Any logic declaration, declare a method is nothing but where you have to do within the class level. Any Java code you can write. Completed, right? So that's all. This is the last point what you have to aware with respect to the switch. That's all. There ends selection statements and the switch statement also.